Let's take a few minutes and talk about how to determine the domain and range of functions. Now, in the world of math, hopefully all of you understand, for instance, in a few minutes, we're going to look at a graph of a function. This is the function that we'll be looking at. F of x equals x cubed plus, start this again, f of x equals x cubed plus x squared minus 2x. Now, oftentimes in math, you'll just be given a function, and you'll oftentimes be asked to give the domain and range. But other times, we take this function, or you're not even given this function as an expression, but you're just given the graph of the function, and you're told here's the function. And then by looking at this graph, you're asked to find the domain and range. And once again, let me say this again. I'm using a sort of a computer-generated tool to create these graphs. Anytime you see the graph go to the edge, I'm not going to do this every time, but just know that there's an error here. These keep on going in that same direction. That'll become important when we talk about finding the domain and range. So let me take a quick minute and give a definition of domain and range, and then we can see how that applies to graphs. You're going to find out actually to find the domain and range when you're given the graph of a function is pretty straightforward. It's not too difficult once you sort of grasp what is going on. We talk about domain and range. I guess I could write of a function. Now it's interesting how I'm going to define domain and range, especially the range in a minute. You'll see how I sort of, once again, use the fact that f of x and y are interchangeable. You can have f of x with function notation, or you can have, so in other words, this function could also be written as this equation, right? We've gone over that many times before. But let's do domain first, because it's very straightforward. Here's how I like to define domain of a function. The domain is all the, should I say, usually I say possible. Let me write it here, but I'm thinking out loud, all the possible values of x. I think that's okay. I thought about saying just all the values of x. So it means the same thing. And then range, it's almost the exact same verbiage. The only difference is the range are the possible values of y. And this is why I talk about going back and forth. You could think of range as all the possible values of f of x, but with domain and range, I don't know, it just seems a little more clear to talk about x and y. But of course, we can always think of y as the same thing as the function. So this may not be very clear. So I think the easiest thing is, let me go to a graph, and then by looking at the graph, try to describe what we mean by domain and range. You look at a graph that's pretty straightforward. So, right, so here's my x-axis, this is my horizontal axis. And like I said, this is actually the graph of this equation. So it's a function. And when I say what's the domain of this, what I'm saying is I'm looking at my x-axis and I'm saying, here's the way that I think is easiest to think about it. If I go to the far left side of my graph, I want to, in a sense, find how far to the left does my graph go? In other words, another way of thinking that, what's the smallest value of x for this graph? How far does this graph go to the left? Well, if you think about it, even though this is going down pretty sharp, it's still also moving to the left. And since this goes on forever and ever, theoretically, how far to the left does this graph go? Well, theoretically, you would say it actually goes out to negative infinity. Another way of thinking about it is if I said, let me just sort of give you I'll just name some random values of x, and then let's decide if the function exists at that value of x. Well, if I was to say, well, how about when x is -1? Well, when x is -1, here's the function. Yes, the function exists when x is -1. How about when x is -2? Well, here's the function. Now, how about when x is -3? It's here. Now you can tell, actually, this graph sort of gets cut off, but -3 is like this, and you can see as this graph keeps going on that the function exists when x is -3. And now, since this continues to get wider and wider and move to the left, hopefully you can see, if I say, well, how about x -4? How about x -5? How about x of -20? How about x of -100? Since this thing goes on forever, matter of fact, it goes on to negative infinity, you realize that actually all the negative numbers, for every negative value of x, there is a function. Domain and range, normally we express it as an interval, right? So I'm saying, what's the smallest value of x where this graph exists? Well, since this graph goes all the way to the left forever and ever, we start by saying, therefore, the domain starts at negative infinity. In other words, these are the values of x where this graph exists. Now I say, how far to the right does this graph go? Another way of saying that is, what's the largest value of x where this graph exists? And once again, even though it's pretty steep going up, it's still moving out to the right. And eventually, even to the right, it's going to go to infinity. So now I think to myself, okay, so what's the largest value of x as I trace this graph out to the right? Well, since it goes on forever and ever, largest value of x would be infinity. So if you think about the domain, all the values of x for this function, it starts at negative infinity and it goes to positive infinity. Let me just give you another quick example, just as a way of comparing, which will help to make sure you understand this principle. How about, we'll come back to that graph, but let me grab this one, which is sort of interesting. So if you're given this function, here's the equation for this function. It's a little bit different. I don't think we've seen one of these before. It's like a parabola, but it's sort of laying on its side. So here's the origin. Now someone looked at this graph And they said, what's the domain? Once again, I think with graphing, probably the easiest way to determine the domain is think to yourself, what's the farthest, what's the smallest value of x for this function? How far to the left does the function go? With this one, because this keeps on going out to the left forever and ever, how far to the left does this function go? Well, it went clear to negative infinity. But this is different because how far to the left does this function go? It looks like the farthest it goes is right here, because then it starts going back to the right. In other words, all these values of x in here, when x is 1, when x is 0, when x is -1, there is no function there. The idea of the domain is, give me the range of values of x where the function exists. So I'm going to find the smallest value of x where the function is there. And then I'm going to find the largest value of x where the function is there. So here's my function. It's this graph. What's the smallest value of x? It's right here. If I look at my scale, this is 2. Now it's interesting. You can see this graph actually touches, it actually equals 2 here. So if I'm writing this as an interval, I put a bracket, whoops, because I'm going to include this value of 2 here. And then I say, okay, so this is the smallest value of the function where the graph exists. It goes all the way here to 2. But then what's the largest value of x where this graph exists? Well, you can see actually both the bottom and the top, they go on to the right and they go on forever. Once again, I could put infinity in here. So the largest value of x for this function is going to be infinity. So the domain of this function is 2 with the bracket to infinity. So once again, what am I saying here? I'm saying for this function, looking at the graph of the function, what are the possible values of x? Well, the function starts when x is 2, and it goes on to infinity. It's like one more like a standard parabola. Once again, this is, I guess, the equations on the back. Here's the equation or the function of this graph. And now I just want to look at this graph and I want to determine the domain. So once again, x-axis. Looks like here's the origin. So domain, once again, I'm looking at my graph and trying to see what's the smallest value of x where this graph exists and what's the largest value of x where this graph exists. But once again, since these come to the edge of the paper, I know that they actually keep on going the same direction. So it's just going to get wider and wider. This is going to go farther to the left, this will go farther to the right. So you say, well, what's the smallest value of this graph of this function as I move to the left? Well, it's eventually going to go to negative infinity. And how about to the right? So you'd say, the domain is negative infinity to infinity. Now, I think I discussed this before. I can't remember the context, but you have an interval of that negative infinity to infinity. Sometimes people will just write all real numbers, or sometimes this is usually the symbol for all real numbers. Any one of these are fine. Now let's go back before I do a few more, even sort of more complicated graphs. Let's go back and talk about range, because now that we understand domain, range should be pretty straightforward. So domain is all the possible values of x. What we did to find the domain is you go look at our graph, and we determine what's the smallest value of x where the graph exists, and then what's the largest value of x where the graph exists, right? Well, for range, if you're looking at y, range we could think of as looking up and down. And by the way, years ago, when I was learning this, sometimes I was trying to think, well, somehow I've got to remember domain, we're talking about values of x, range, we're talking about y. How can I remember those? And I remember, since domain and range was very new to me, I wasn't sure. And here's what I did years ago, and it helped me to the point where now I don't have to think about it, but at the time it helped. I just think of the alphabet, right? Domain and range, D comes before R in the alphabet in the same way that X comes before Y. So if I'm asked in some problem to determine the domain and I think, oh boy, is domain X or Y? I just think of the alphabet. Domain comes before range, just like X comes before Y. All right, so let's look at the range. So the range, we're looking at Y. So basically, it's also going to be in the form of an interval. And the idea is for the range, you want to find the smallest value of the function where the graph exists. How far do I have to go where the graph exists? Well, for this one, since it's going down, and it looks like it continues on forever, you can imagine eventually, your x-axis is going to go to negative infinity. So therefore, the range, the smallest value of the function where this graph exists, it's going to be negative infinity. And then you say, okay, what's the largest? How high does this graph go? What's the largest value of the function for this graph? Once again, since it goes up and keeps going up and goes up forever, you just say the largest value where the function exists is going to be positive infinity. So this sort of makes sense because this graph here, it's going up and it's getting wider and it goes on forever. The other side, it goes down, it gets wider, it goes on forever. And the thing it doesn't have, which we're going to talk about in just a minute, is when you look at your highest and lowest points, either for the function or for x and y, the thing you always have to take into account and check for and look for, are there any gaps or breaks in your graph between your highest and lowest points? I want to do some examples of those in just a minute, and I think it'll be clear what we have to take into effect. But let's finish up these graphs where we started to find the domain. So this one, domain and range, you could have said the domain is all real numbers, the range is all real numbers, if you wanted to. Remember this one? We've done the domain. We said the domain starts and includes 2, and it goes to infinity. But how about up and down? So once again, the range, how far down, what's the smallest value of the function this graph goes to? Now this graph is pretty horizontal, but even though it's horizontal, it's still going down, and it will continue to go down. So therefore, the smallest value for the function It's gonna be negative infinity. Here's my x. Now, what's the largest value of y for this graph? Well, if I go here, even though it's moving pretty sharply out to the right, it is still rising some. So if you go long enough, it's still going to keep going up. So actually, how high does it go? It goes to infinity. Let's look at the range for this one. Already done the domain. The domain is the values of x, the left and the right. How far to the left does this go? It goes on forever. Goes to negative infinity. How far to the right does it go? It goes on forever. Positive infinity. How about the range? The range is the value of the function, or the value of y, or the up and down. How far down does this go? Well, you can see here, down here when there is no function. In fact, the function doesn't start until right here. And if you look, this is a value of 2. So the function starts at 2. Now it includes 2. And then it goes on to infinity, since both of these keep going up. So the range is 2 to infinity, right? This is 2 here, 2, 4, 6, 8, 10. This is 2. So hopefully that's clear. But we had, okay. All right. Now, the one thing I want you to notice in all these 3 examples so far, there are no breaks or gaps in these graphs. We talked about this is like a continuous function. All 3 of these are continuous functions. And just be warned, a continuous function doesn't mean that the domain and ranges are going to be negative infinity to infinity, because you can have things like a parabola where obviously there's lots of values of the function that there is no range there. Like this one, the domain starts at 2 because to the left of the domain the graph isn't there. But the key thing now we're going to look at is sometimes when you look at domain and range, you look at the smallest and largest values, and that's your answer. But then you also have to check and make sure there's no gaps or breaks in between. So what do I mean by that? And then how would that affect the domain and range? Let's look at something like this. Once again, bottom, here's a graph of the function x minus 1 over x minus 2. Ends up looking like this. Now, we've talked before recently about this thing called asymptotes. You see here we have a vertical asymptote, and here we have a horizontal asymptote. If I was to look at this graph and say, what's the domain? What I'm doing is I'm looking for the smallest value of x where this graph exists. And then I'm going to look for the largest value of x where this graph exists. So domain are like x's. So I go here to the left as far as I can. And I realize here's my graph, and this is going on forever. So eventually it's going to get to negative infinity. Now, as I move to the right, I notice the functions here everywhere, but this thing turns down and it ends up having like a vertical asymptote where my graph turns down and begins to hug this dotted line. But you notice there's like a break or a gap. If I say to myself, well, how far, what's my largest value of the function in terms of x? Once again, this thing goes on forever. someone might say, therefore, the domain of this is negative infinity to infinity. What that says is this graph, this function exists for every single value of x. No matter what value of x you choose, you can go look and see that the graph does exist. But you know what? That's not going to be correct, because the problem is, what if I say, well, hey, what about when x is 2? What's going on when x is 2? You can see the problem is if you plug in 2 and for x the equation, you have a 0 in the denominator, and we learned you can't have that. So bottom line is, there's like a break or a gap in my domain. The smallest value of my domain is negative infinity, and it comes in here as it gets closer and closer to x equals 2. There's an asymptote, which means there's a break or a gap. So it's almost like you have to express the domain in like 2 intervals. The first interval starts at negative infinity, and it goes all the way to, this is to negative infinity, and it goes all the way. It never quite gets there, but it's getting very close to 2. But never quite gets there. But then you have to jump over x equals 2, just that one number. That's all you have to exclude. In this case, I'll put a union. And then once again, you go ahead and pick up your function and move to the right. How far does it go to the right? Well, first of all, where does it start? It starts at 2. And how far to the right does it go? It goes to infinity. Actually, the domain, this function, look at this graph. It's negative infinity to 2, union with 2 to infinity. Sometimes some people will say, this is probably okay. When they look at this, they'll say, that stands for all real numbers, meaning x can be anything. All real numbers except in other words, there's just one value of x. That's a problem. So they say the domain x can be anything you want it to be, except x cannot be number 2. So sometimes when we have graphs with a break in it, how about the domain? I mean, the range. How about the up and down? How far down does this go? Looks like it probably goes to negative infinity. So the range, if I start way at the bottom, starts at negative infinity. If I just go to the highest point, it'd be positive infinity. But once again, it's almost like with domain and range, you can check the high and the low, but then you have to check in between as if there's any breaks or gaps. Lo and behold, there is another break or a gap here. It looks like it occurs when the function is at 1. So the range must start at negative infinity, and it goes to 1. It gets very close. And then we have to jump over the value of 1 for the function. So we union and we jump and we pick up again with 1 and then go to infinity. So hopefully you get an knack what's going on. I don't think it's really that hard as you just see it, and it becomes pretty straightforward. Key here as an example is you just look at the domain in terms of the smallest, largest value. You might think negative infinity to infinity, but because there's a break or a gap, you have to take that into account. Because once again, what is the domain? All the possible values of x. You know what? X equals 2 is not a possibility, because you put that into the equation, you get a 0 in the denominator. So that's what's going on here. All right, here's another one with some asymptotes and breaks and gaps, even a little more complicated. The function, the equation is not that complicated. This equation right here, it's pretty simple, but when you graph it, is what you get. So we're asked to look at this graph of the function and find the domain and the range. So I can see we're looking at domain. I got actually a couple of gaps or breaks, actually a couple of asymptotes I'm going to have to account for. So first thing is the domain goes all the way to the left. So it's going to start at negative infinity. But now, as I move to the right, as x approaches -1, it's like I hit a wall. Or it's like a break or a gap. So I can go negative infinity to -1. And then once I get past 1, here's my function down here, and it picks up again. It looks like all the numbers are pretty much covered between -1 and 1. So I union it with -1 to 1. Now I have to make another jump, another break, another gap here at x equals 1. And then I can pick up here, union 1 to infinity. So since this graph, in terms of thinking about looking at the values of x, has like 3 pieces to it, I have to give intervals for all of those. Now let's think about the range, the up and down. Well, you always start out with how far down does the graph go. You can see it goes down like this. These probably go on forever. So you would say negative infinity. Now here, if you think about up and down, there is a gap here, actually from 1 up into 0. There's nothing there. So I have to count for that. So if I start at negative infinity, I have to go to 1. I include 1. Then I have to sort of jump up to where the graph starts again. Looks like it starts again at 0. So I union it from, yeah, I think I will. Yeah, it's going to be, the function is 0. And then it goes up to infinity. So it's interesting with the domain, your gaps were just one value of x. But here, with the gap and the range, there's a gap from 1 to 0. All right, now the last thing is for domains and ranges, maybe think what happens with piecewise functions. So this is an example of one we looked at before. This was a continuous piecewise function, but they're going to ask for the domain and range. Well, the domain is the left and right. How far to the left does this go? Well, I think it goes on forever. Now you think, how far to the right does this go? First it goes to here, but then it heads straight out to the right. Well, this is a continuous function. There are no breaks or gaps. When I think about the domain, no matter where I go on this x-axis, the function is going to be there someplace. So the domain is negative infinity to infinity. Now the range, a little bit different. Range is up and down. So how far down does this graph go? It looks like the smallest it ever gets is 0. So and actually you include 0, since it's a nice number. How high does this go? Well, it sort of stops here on the right side, but the left side it still keeps going. So The range is going to go from and including 0 to infinity. And the last one very quick. So you notice this is a continuous function. There's no breaks or gaps. This next one is very similar, but there actually is a break or a gap. Although if you look closely, if you think about values of x, you go here, it jumps down here and keeps going. So there's a break or a gap, but the question is, how does that affect the domain and range? So let's think about domain. If we start to the lowest value, how far to the left does this graph go? Well, obviously this goes on probably forever. So you start with negative infinity, and then you come back. What's the largest value for x, the right side of the function or the graph? You got to jump here, but is there a gap? So let's think about this. I'm coming along here. When x is 2, this is the value of my function. And then right away, it jumps down and it starts tracking this. So even though it's not continuous, I can't sketch this out because this break, but as it turns out, whoops, I meant to put range here. But as it does turn out, the range is negative infinity to infinity. So it's almost like any value of x I choose on this graph, the function is going to exist. How about the range, the up and down? Well, you can see there's not even any graph down here. The graph doesn't start to right here at 0. Then how far up does it go? Well, you can assume that these go on forever. Oh, sorry. It doesn't go on forever. Interesting. This one stops. But this side does go on forever. So this is going to keep climbing, and eventually it's going to get to infinity. This one stops here, but that's okay because I can look at any part of the graph and get these answers. So the up and down starts at 0. I should have put a bracket here. If I just look at this part of the graph, I would say it stopped here, but then I can remember the other side of this sort of parabola part, and it just goes up and keeps on going and going. So eventually, left-hand side of this graph will eventually get to infinity. So that will be your range. All right, well, I've taken a fair amount of time to talk about domain and range, but hopefully, I think it's a pretty simple prospect, especially when looking at graphs of functions, that you'll be able to get the domain and range pretty easily.